let's consider this problem wherein you have a reaction of hydrogen and bromine in their atomic states forming hydrogen bromide. And you're given here the enthalpy of the reaction, which is minus 366 kilojoules per mole. Okay? So, enthalpy siya at the standard temperature of 298 Kelvin. And assuming na for HBr, yung heat capacity is given by a certain expression. So, ito yung heat capacity and you have the expression 25.1 plus 8.37 times 10 minus 3T. And we are assuming here that both hydrogen and bromine are ideal monoatomic gases. So let's calculate delta H or the enthalpy at a higher temperature of 1000 Kelvin. So ibig sabihin, ang sinasabi ng problem na to, meron kang given na enthalpy already at 298 Kelvin. Pero paano kung gusto mong i-calculate yung enthalpy at another temperature? And in this problem, 1000 Kelvin yung hinahanap natin. So yan yung tinatawag nating temperature dependence on enthalpy. So how does enthalpy depend on temperature? So, ang sagot dyan is, if you want to calculate yung enthalpy at a second temperature, and let's do it mathematically. So, you have an enthalpy at a certain temperature T2. It should equal the enthalpy at the given temperature T1 plus the integral from the first temperature to the second temperature, yan yung limits natin, of delta Cp dt. So this equation, which I will now highlight, itong equation na to, ang tinatawag natin na Kirchoff's law. Okay. So let's try to solve the problem using this equation. So, meron tayong hinahanap na enthalpy at 1000 degrees Celsius or rather Kelvin. So, equal daw siya sa given na enthalpy, and ang given sa problem is enthalpy at 298 Kelvin. Okay. Plus integral from 298 to 1000 Kelvin of delta Cp dt. Okay, let's first identify ano yung delta Cp or yung change in heat capacity. So magkakaroon ba ng change in heat capacity? So yes, because may reaction na nangyari. So specifically, yung ating change in heat capacity is just your products minus reactants. Okay. Now, ang given sa problem is yung heat capacity pa lang nung product, which is HBr. So 25.1 plus 8.37 times 10 raised to negative 3T. Okay, product pa lang to. So, let me label here na siya ay for your product. Okay, minus that of your reactant. Okay. Now, sinabi kasi sa problem na yung H tsaka yung Br, which are your reactants, these are ideal monoatomic gases. So, if they are monoatomic gases and they are perfect gases, alam natin na ang Cp will be equal to 5/2 R. So 5/2 R for hydrogen and another 5/2 R for bromine. So therefore, ang delta Cp natin na pwede natin gamitin mamaya sa equation will be equal to, okay, let's compute. So this will be equal to minus 16.47 plus 8.37 times 10 raised to negative 3t. By the way, ang R na ginamit ko dito is 8.314 joules per Kelvin mole. And yung ating temperature naman is in Kelvin. Okay, but basically, yan yung ating bagong expression, which is delta Cp. Now, we can now plug in that expression or value sa ating equation. So again, we are looking for the enthalpy at 1000 degrees Celsius, or Kelvin rather. So, ano yung enthalpy at 298 Kelvin? Given yan sa problem, negative 366 kilojoules. Gawin nating joules lang. Okay. So, I'm now using this working equation. Plus, integral from 298 to 1000 of your delta Cp. And the delta Cp expression that we have now is minus 16.47 plus 8.37 times 10 to the negative 3 times t dt. And you can actually use your calculators if you have your Casio FX series. Meron dong function of definite integral, so you can input this equation directly to your calculator at ang lalabas na enthalpy or sagot at 1000 Kelvin ay negative 373.7 kilojoules per mole. Of course, I already converted this to kilojoules. So, yan na po ang ating sagot. So, nakita natin na at a certain temperature, let's say T1, meron tayong change in enthalpy from the reactants to the products kasi enthalpy of reaction ang pinag-uusapan natin. Now, pag iba yung temperature T2, according to Kirchoff's law, may iba rin yung enthalpy, and what happened or what we observe is mas malaki yung change in enthalpy doon sa pangalawang temperature. So, yan yung sinasabi nating temperature dependence ng enthalpy. Now, let's solve another problem. Halimbawa, mayroon tayong amino acid. So, this is now a biological application. Meron ako ditong amino acid which I will draw. So, we have an alpha carbon. Okay. Hydrogen. This is the carboxyl group. This is the amino group. And yung kanyang side chain ay CH2 COO minus. So this is your amino acid na glutamic acid. Okay. Now, in your cells, ang nangyayari, if you want to obtain glutamine, so magre-react siya sa ammonium ion. Okay, of course, usually kapag nasa cell yan, yung reaction natin ay catalyzed by a certain enzyme. So the enzyme that is used to catalyze this reaction is glutamine synthase. Okay, so ang nangyayari dito is that your glutamic acid, nako-convert siya into another amino acid which is now your glutamine. So from glutamate, naging glutamine. Ano ba yung itsura ni glutamine? So meron kang carboxyl group, meron kang amino group na naman, and yung side chain niya is something like this. Okay. So from glutamic acid, naging glutamine. Okay, let me just change this to NH2 rather. Okay. And meron kang isang water pa na na-form for this reaction. Next, I will provide some additional information or data. So, first, meron tayong given na enthalpy of reaction for this reaction, which is at 298 Kelvin. Ang value niya ay 21.8 kilojoules per mole. Ang kulang na lang natin na data is yung mga heat capacity. Now, I have the data already for the heat capacities for glutamine, glutamate, water, and ammonium ion. Okay, so ang tanong dito is let's determine, okay, or calculate the change in enthalpy of reaction at maybe 37 degrees Celsius, which is our body temperature, right? Or in Kelvin, that's 310. So how do we approach this problem? Unang-una, in your Kirchoff's law, so let me write again yung Kirchoff's law. So you want to determine the reaction enthalpy at a certain temperature T1 or T2. It will be equal to the reaction enthalpy at a given temperature plus the integral with the limits of T1 to T2 of delta Cp dt. So we need delta Cp. And thankfully, meron tayong data available which will produce a constant. So, si delta Cp, ang gagawin lang natin is you will first consider the heat capacities of the products. So, meron kang heat capacity ni glutamine aqueous bilang isa sa mga product plus heat capacity ni water liquid, another product of the reaction as you can see above. Okay. Minus yung kay reactants naman. So what are those? Heat capacity ni glutamic acid plus heat capacity nino ammonium ion. Yeah. So, you're given all the information here. So, you just have to substitute and later on, malalaman natin na ang heat capacity will be equal to, let me calculate, 5.4 joules per Kelvin mole. Now, let's go ahead and convert this to kilojoule per Kelvin mole. So, I just have to add or to multiply rather 10 to the negative 3. So kilojoule na yan per Kelvin mole. Okay, so we can now substitute. We are after the enthalpy of reaction at what temperature? 310 Kelvin. So enthalpy at 298 Kelvin given yan or 25 degrees Celsius. So that will be 21.8. Naka-kilojoules per mole na siya. 21.8 plus integral from 298 to 310. So this is just a minor difference of delta Cp, which our value is right here. So 5.4 times 10 raised to negative 3 and dt, right? So ano mangyayari? Magiging 21.8 plus constant yung heat capacity natin times 10 raised to negative 3 times delta T, which is we have now the difference between 310 minus 298. At ang magiging sagot dito using our calculators, of course, the enthalpy change at 310 Kelvin or 37 degrees Celsius is 21.9 kilojoules per mole.